Hello, everybody. Welcome to my YouTube channel. Today, we're going to be talking about the chapter Language of Chemistry. So, in this chapter, we're going to be talking about three topics: symbols and valencies, chemical formula and equations, and atomic and molecular weight. So, what are symbols? Symbols are used to represent elements using the short forms of their names. They're usually represented using the first two letters of the name of the element. Example, hydrogen is represented using the letter H, and aluminium is represented using the letters Al. But sometimes they're also represented using their Latin names. For example, in the case of sodium, whose Latin name is natrium, so it's represented using the first two letters N and A. Okay, so let's talk about the definition of a symbol. Atoms of elements are represented in a simplified or short form by the abbreviated names of elements called symbols. So these are a few examples of symbols of a few elements from the periodic table. So we're going to be needing them a lot in the upcoming chapters. So let's talk about radicals now. What is a radical? An atom or a group of atoms of the same or a different element carrying positive or negative charge. Mm. There are two kinds of radicals, positive and negative. So if you look at positive radicals, they have a positive charge in them, and negative radicals have a negative charge in them. So for example here, an element aluminium has a positive charge of 2 plus, and a compound NH4, which is ammonia, has a positive charge of 1 plus. Here, an atom, fluorine, has a negative charge of 1 minus, and CO3 has a negative charge of 2 minus. So these are examples of positive and negative radicals. Valency. Valency is the combining capacity of an element. Let's take a closer look at an example of an atom of oxygen. The atomic number of oxygen is 8, which means the number of electrons in an atom of oxygen is 8. So the electronic configuration will be 2,6. We also know that the stability can be attained on having 8 valence electrons. This means that there needs to be 8 electrons on the last or valence shell of an atom of oxygen. So here, oxygen has 6 electrons in its valence shell, which means it's going to need 2 more electrons to attain stability. And we also know that an electron carries negative charge. So when an oxygen atom gains 2 electrons, that means it's going to gain a negative charge of 2. So thus the valency of an oxygen atom will be -2 or -2. So that's what valency is. So let's look at a few examples. In case of water, H2O, we know that oxygen requires 2 electrons to attain stability. So in case of water, the oxygen atom gains 2 electrons from the 2 atoms of hydrogen. So thus it forms H2O. Similarly, in the case of ammonia, the valency of nitrogen is 3 minus, which means it requires 3 electrons to attain stability, which it gains from the 3 atoms of hydrogen bonding with it, thus forms NH3. Similarly, in the case of methane, carbon has a valency of 4 minus, so it gains 4 electrons from the 4 hydrogen atoms which are bonded to it. Now let's talk about variable valency. Variable valency is when an element exhibits more than one type of valency. Let's take an example of iron. Iron exhibits 2 plus and 3 plus. This means it can donate either 2 electrons from its valence shell or 3 electrons from its valence shell in certain cases. So there are different kinds of namings for it. So you name the lower valency as with the suffix of OUS, and a higher valency with the suffix of IC. So here in the case of iron, it's going to be ferrous and ferric. These are a few more examples of um, elements exhibiting variable valency and how to name them. So you have mercury, lead, gold, and tin. So that's all for this video. Thanks for watching. Please do like, subscribe. Hope you all enjoyed it. Thank you.